Plot the function on the left. Based on the plot alone, without looking at the function, argue a case. We are given these functions. Question number 1, x to the power of 4. Question number 2, x cubed. Question number 3, negative of x to the power of 4. Question number 4, negative of x cubed, and so on. So plot the function on the left. Based on the plot alone, without looking at the function, argue your case. Argue a case for what? Well, for the following. Is the degree of the polynomial even or odd by just looking at the graph? All right. Can you say anything about the behavior of n's? What is the number of x-intercepts? What is the number of turning points, if any? Is the leading coefficient positive or negative? What is the minimum possible degree of the polynomial? X to the power of 4, when we plot it, we get that. So based on the plot, what do we see? We see that the degree of the polynomial is even. Why? We have both ends pointing up. So degree of the polynomial is even. So degree of the polynomial is even. No question about that. What is the behavior of ends? We have both ends pointing up. We have both ends pointing up. So no question about that. How many x-intercepts? We only have one x-intercept. So 1. No question about that. Number of turning points, just 1. Number of turning points is just 1. What about the leading coefficient? Is the leading coefficient positive or negative? The graph opens up. So it has to be positive. The leading coefficient has to be positive. So you can have either x to the power of 2 or x to the power of 4. Both are even. We only have one turning point, so we are okay. You know the quadratic function curve, correct? For the quadratic function curve, it looks like that or like this. There's only one turning point for quadratic curve, ax squared plus bx plus c. For the function involving x to the power of 4, you can have different kinds of graphs, but either both ends will be pointing up or both ends pointing down. For our case here, both ends are pointing up, so the coefficient of x to the power of 4 is positive. So by just looking at the graph, we are not 100% sure whether it is a quadratic function or a quartic function. Quartic. Quartic function involves x to the power of 4. What is the minimum possible degree of the polynomial? And that is 2. Minimum possible degree of the polynomial 2. Why? We only see one turning point for the graph that is given to us. If there's only one turning point, the degree could be 2, degree could be 4. Question number 2, what if the function is x to the power of 3? First of all, let's see, what is the degree of the polynomial? Is it even or odd? When we have a curve with one end opening up and the other end opening down, it is a cubic function. So our polynomial is odd. What about the behavior of ends? One end is up and the other end is down. One end is up, the other end is down. Number of x-intercepts. We only have one x-intercept, and that is right here. There's only one x-intercept. No question about that. Number of turning points? No, there is no turning point. If you have a curve like this, there is a turning point. If you have a curve like this, there is a turning point. But when you have a curve like this, there is no turning point. So number of turning points? None. No question about that. Leading coefficient, is it positive or negative? Well, let's assume that it is a cubic function. And if it is a cubic function, we have x to the power of 3, right? So we have x to the power of 3. On the right side, when x is equal to 1, So we have a n x to the power of 3. What is the net effect of that? A n x to the power of 3. When x is positive, if we end up with a positive number, then a n has to be positive. On the left side, if you have x negative, what is cube of a negative number? It will be negative. And that times another number is negative. That means what? That this number has to be positive. So our leading coefficient, an, is positive. The leading coefficient is positive. No question about that. Minimum possible degree of the polynomial, 3. Why not 1? Well, when the polynomial is of degree 1, you have a linear equation. And whenever we have a curve can never be a straight line. So for that reason, we exclude linear equations. A polynomial of degree 1 is excluded. So then what are we left with? Minimum possible degree of the polynomial, 3. Next is f of x equals negative of x to the power of 4. Negative of x to the power of 4. Well, this is our graph. So the graph is opening down. So it is going that way. All right, what is the degree? It is even. Why? Both ends are pointing down. Both ends pointing down. So no question about the even, no question about pointing down. Number of x-intercepts, just 1. No question about that, right there. Number of turning points, 1. No question about that. Leading coefficient, is it plus or minus? It has to be negative. It is opening down. So it is negative. What is the minimum possible degree of the polynomial? Now, you may be tempted to say it is 4. Well, because we only saw one turning point, it could be x to the power of 2 as well. Can you say whether it is x to the power of 4 or x to the power of 2? Well, if the numbers are given, yes. All right. So what is the minimum possible degree of the polynomial? It is 2. Could be 4. And we know better, it is 4. What is the leading coefficient? Leading coefficient is negative. It is opening down. Negative. Well, next is question number 4. Negative of x to the power of 3. Negative of x to the power of 3. When x is negative 1, your function is positive. So negative 1 to the power of an odd number, let's assume that number is 3. So negative 1 to the power of 3 should be negative, right? Negative 1. Negative 1 times negative 1 times negative 1 is positive 1 times negative 1, and that is negative 1. So if x is negative 1, you get negative 1. Negative 1 to the power of 3 is negative 1. And that times the coefficient is positive. So what can we say about that coefficient? It has to be negative. So our coefficient, leading coefficient, is negative. No question about that. Is the degree even or odd? It is odd. 1 end up and 1 end down. 1 end up, 1 end down. Behavior of ends, 1 end opening up and 1 end opening down. Number of x-intercepts, just 1. Number of turning points, none. Remember, like this, 1, like this, 1. But when it is like this, you have no turning points. Minimum possible degree of the polynomial, 3. It could not be 1. If it is 1, it is a straight line. So we exclude straight lines. So it is 3. Next is, again, based on the graph, what do we see? We see both pointing up. That means what? The degree is even. The degree of the polynomial, it is even. No question about that. Both ends are pointing up. Number of x-intercepts, 1, 2, 3. You have 3 x-intercepts. Do not forget, we are just looking at the graph. We don't know what the function is. Number of x-intercepts, 3. Number of x-intercepts, 3. No problem about that. Number of turning points, 3. Where are those turning points? One is here. The other one is here. And the third one is here. So we have 3 turning points. Number of turning points, 3. No question about that. Leading coefficient is plus or minus? It has to be plus. positive. All right. Both ends are pointing up. Both ends are pointing up. What is the minimum possible degree of the polynomial? It is even and it is 4. Why not 2? Well, if it is 2, we only have one minimum or one maximum. If it is 4, we can have 3 turning points. 3 turning points. 1, 2, 3 turning points. Because we have 3 turning points, we have to exclude quadratic equations. So we go with minimum degree 4. Next is f of x equals x cubed minus 12x squared plus 20x, and we get this curve. So based on just that curve, what do we see? We see that what is the degree of the polynomial? Odd. What is the behavior of ends? One end is pointing up, the other end is pointing down. Number of x-intercepts? 1, 2, 3. 3 x-intercepts. Number of turning points? Number of turning points is 1 and 2. An x3 is negative, right? Our function, the value of our function is negative on the left. So when x is negative, the cube of that will be negative, and that negative times an is negative. So what can you say about an? It is positive. So what is the leading coefficient? It is positive. Leading coefficient is positive. No question about that. Minimum possible degree of the polynomial, it is 3. Minimum possible degree of the polynomial, it is 3. Why? Because we have 2 turning points. One end is pointing up, one end is pointing down. Negative x to the power of 4 plus 18x squared plus 20x. What is the degree? Again, you see both ends pointing down. What is the degree of the polynomial? It is even. No question about that. Both ends are pointing down. No question about that. Number of x-intercepts? 1, 2, 3, 4. No question about that. No question about that. Number of turning points? 3. Number of turning points? 3. 1, 2, and 3. 3 turning points. No question about that. Leading coefficient, is it plus or minus? Negative. Negative. Both ends are pointing down. Minimum possible degree of the polynomial, it has to be 4. Why not 2? If it is 2, you only have 1 turning point. Because we have 1, 2, 3 turning points, minimum possible degree of the polynomial is 4. Next is f of x equals negative 5x cubed plus 18x squared plus 20x. So once we have our function, we plot it, and this is what we get. We see one end is pointing up, the other end is pointing down. What is the degree of the polynomial? It is odd. Number of x-intercepts? 3, 1, 2, 3. No question about that. Number of turning points? 2, 1, and 2. 2 turning points. Number of turning points? 2. So the degree has to be at least 1 more than 2. Leading coefficient is plus or minus. On the left side, when x is negative, y is positive. So that means what? Your an x cubed is positive. When you put x equals negative, it's already a negative number. So to make it positive, the leading coefficient has to be negative. So it is negative. So we have no question about that. Minimum possible degree of the polynomial, it is 3. And this is George Mathew signing off. Good luck.